The philosopher David Hume identified a trap centuries ago. You cannot logically derive an ought from an is. Today, AI developers have walked right into it. The is represents objective, factual knowledge about the physical world. It is the realm of physics, mathematics, and verifiable data. The ought represents human preferences. It encompasses moral conclusions, cultural attitudes, and socially contingent values. This diagram illustrates the flaw in reinforcement learning from human feedback. It shows the result of treating emotivist preferences as objective facts. Faced with contradictory training data, the model has no principled way to reconcile them. It satisfies the preference signal while masking its internal disagreement. Standard RLHF encourages the model to perform alignment to maximize its score, leaving the internal world model and the human model in a state of unresolved conflict. This wastes massive amounts of compute on performance and produces specific, predictable pathologies. Models become sycophantic, constantly agreeing with the user, and dangerously brittle when pushed into unfamiliar conversational territory. Because aggregated preferences are not logical derivations, current alignment methodology hits a logical impasse. Large language models are forced to maintain two distinct internal representations simultaneously. The first is a rational world model, derived directly from the training data. This maps the causal structure of the universe. The second is a human model, built from that exact same data. This maps our culturally contingent, often logically contradictory behaviors. No text corpus can perfectly reconcile these two. In many domains, an accurate modeling of humans requires preserving our inconsistency rather than resolving it. This diagram tracks where these internal models intersect. In mathematical domains, they smoothly align. But in social reasoning, they diverge, creating a fracturing effect called jagged intelligence. Forced to output a coherent response, the model improvises, resulting in confident hallucination at its jagged edges. To fix jaggedness, the architecture must provide a framework that allows the model to hold these internal contradictions intact. Building that framework requires replacing the current objectivist training assumption with an emotivist layer. The philosophers A.J. Ayer and C.L. Stevenson established emotivism as a meta-ethical frame in the mid-20th century. While an objectivist treats the statement, "this is good," as a verifiable truth, an emotivist treats it as an expressed attitude, an endorsement that only makes sense within a specific human context. We apply this to AI by shifting from preference training to a teaching alternative. Instead of training the model to adopt human feedback as ground truth, we teach it to analyze that feedback as subjective data. The model learns explicitly that human preferences are emotionally motivated